Hi, Eric here. So, in the last video, I showed you how to balance simple chemical equations. This time I'm going to show you a trick that I find comes in handy really often. I call it the half trick. So, what were the rules for balancing chemical equations? Well, remember, they came from the law of conservation of matter, which states matter can neither be created nor destroyed, which for us meant that we had to have the same number of atoms of all elements on both sides of the chemical equation. Well, there's one other rule that I didn't tell you at the time, and that is that coefficients have to be the lowest whole numbers that work. What we're setting up is a series of ratios, and we'd rather talk about a ratio of 2 to 1 than a ratio of 1 to 1/2. So let me show you how this works. Okay, so I've got my notebook set up with an unbalanced chemical equation. This is, by the way, the reaction of butane plus oxygen to form carbon dioxide and water. If you use a butane lighter, that's what's going on there. And you can see I've got my chart set up, and I've counted out my carbons, my hydrogens, my oxygens, etc. So let's start making changes and seeing what happens. Let's fix the carbons. Put a 4 here, which changes that. Don't forget to change your oxygens. 4 times 2 is 8, plus another 1 is 9. Okay, let's change the hydrogens now. So I have 10 hydrogens here, so I need 10 hydrogens here. I'm going to go ahead and put a 5 in front. 5 times 2 gives me 10 hydrogens. But don't forget, I have to change the oxygens. Now 4 times 2 is 8. Plus another 5 is 13. Okay, so here's the problem. Whatever number I put in front of the oxygen here is going to be doubled because it says O2. Can't change this 2. It's stuck. Don't ever touch those. What I can do is I don't have to multiply by a whole number at first. So what do I want to use? Well, here's real simple. Don't even think too hard about this. I need 13 oxygens, and this is 2 oxygen atoms per molecule. So just use 13 over 2. If you'd rather write that out as 6.5, whatever. Either or is fine. So now this has balanced the chemical equation. But you can't leave it like this. When we balance chemical equations, we always want the lowest whole numbers that work here. So we can't change the ratios, but we have to change the numbers. Well, what do I mean by change the ratios? Not change the ratios, but changing the numbers. Well, remember, there's an invisible 1 here. So this is a ratio of 1 to 6.5. I can make that whole numbers if I double them both. So I'm going to take this invisible 1, I'm going to double it. I'm going to take this 13 halves, and I'm going to double that. So now it's still the same ratio, but they're whole numbers. Whatever I do here, I have to do over here. So this goes to 8, this goes to 10. So the final form, the balanced chemical equation, is 2 butane molecules plus 13 oxygen molecules will react to form 8 carbon dioxide molecules and 10 water molecules. Let me show you another one. Okay, so I have here iron plus oxygen reacts to form this form of rust, which is called iron 3 oxide. My little drawings up here, I have a nail plus some air. How do you draw an invisible gas? I don't know. But you have an iron nail plus oxygen, and they rust up. You've I'm sure, seen this. So let's make the chart. Okay, in this case, what we're going to have to do is we'll start on the left side. We change the irons to a 2. Okay, that's great. But now the oxygens aren't right. Well, this is where you use the half trick. So I need 3 oxygens on the right. I have O2, so I'm going to write in 3 over 2. Can't leave it like this. So what we have to do is double all the coefficients, including this invisible 1. So this becomes 4, 3, and 2. I'm going to rewrite that. Okay, so this is our balanced chemical equation. 4 iron atoms plus 3 oxygen molecules will react to form 2 molecules of iron 3 oxide. There we are. Thanks for watching.